Welcome to CitIQore, a domain-specific application built on top of URBANE's digital twin platform. CitIQore enables users to explore various what-if scenarios that address last-mile logistics challenges. Upon launching the application, users are presented with the option to choose between three primary interventions: last-mile deliveries with ADVs, collaborative delivery between last-milers, and last-mile delivery with e-bikes. As users pass over each option, additional details about the intervention are displayed. In this scenario, the intervention of last-mile delivery with e-bikes will be examined. Users can either create a manual scenario or upload a file containing specific delivery point locations. If uploading a file, users can download a system-provided template to ensure proper formatting. Once a correctly formatted file is uploaded, the system redirects the user to the relevant map region based on the provided delivery points, visualizing them within an enclosed polygon. At this stage, users can continue scenario creation or return to review the uploaded file's details or replace it with a new file if needed. If users choose to create a scenario from scratch, the system displays a map with markers representing various URBANE living labs. Users can navigate the map by zooming into specific areas, choosing a city from a drop-down menu, or clicking on a marker to select a living lab. This action redirects them to a map centered on the selected city. Users then define a polygon to outline the region for the last-mile logistics scenario. This polygon can be adjusted as needed to better fit the scenario's requirements. Regardless of how the polygon is created, whether manually or through file upload, users are then guided to the first mile step. At this stage, they must select between 1 and 3 origin warehouse locations, typically situated outside the city center, and specify the number of parcels dispatched from each. Additionally, users need to place a depot within the predefined polygon. Next, they choose the type of vehicle for transporting packages to the city depot, with available options including conventional and electric vehicles. Following this, users configure the last-mile delivery details. They select the type of last-mile vehicle that will operate from the depot. In this scenario, an e-bike will be used, traveling at an average speed of 15 km per h. Users define the number of vehicles they prefer to deploy and specify the parcel capacity of each. The final step involves entering financial parameters, such as labor cost per parcel for the e-bikes, initial investment requirements, and the projection period. Once all inputs are provided, users press the Calculate button, prompting the platform to process the data through various models to generate simulation results. If the scenario was created manually, the random demand delivery model first generates random delivery locations within the defined polygon. The platform then applies optimization and analysis models. The echelon model calculates the distance traveled by first-mile vehicles, the VRP model optimizes last-mile deliveries, and the EVCO2 and Copert models estimate CO2 emissions generated. Additionally, the cost-benefit analysis model assesses the financial viability of the scenario. Users are then redirected to the simulations page, which displays both ongoing and previously executed simulations. By selecting a specific simulation, users can examine the results through a dedicated dashboard. At the top of the dashboard, a map visualizes key scenario details, including delivery points, the depot, and the warehouse. Users can also review the input data, such as the number of deliveries, selected vehicles, and financial parameters. If the system determines that different number of last-mile vehicles are required to fulfill deliveries, a red warning message notifies the user. The dashboard further presents the simulation results through various graphs, including a pie chart illustrating total CO2 emissions and the contribution of each vehicle type, as well as a bar chart displaying both the total distance covered and the distance covered by each vehicle. The cost-benefit analysis section outlines delivery costs and projects them over the defined time period. Additional information includes delivery locations, the routes each vehicle follows, and the time needed for each package to reach its destination. This table containing the details can be downloaded for further processing. CitIQore leverages the power of digital twins, agent-based models, and AI developed during the URBANE project's lifecycle. It empowers users to explore and analyze various hypothetical last-mile logistics scenarios. As development continues, stay tuned for further updates.